To finish out the section on the fundamental theorem of calculus, we have the concept of average value. So it has the word average in it, and we're going to start by thinking of just a regular average. So the scenario to help us think about this is that there's temperature readings happening, and so it's for the course of a day, which is 24 hours, so 0 to 24. And so let's say that they're taking readings every 4 hours. If you wanted to average those, you would add them up and divide by how many you have. So if you're taking readings every 4 hours, that's 6 readings. You would add up all the temperatures and divide by 6, and that would give you the average temperature. But if you go back and look at the picture, there's this dip that happened between two of the readings. And so you can see that that was not included in the average, and if it had been, it would have affected it because it's quite a bit lower. So they say, what if a storm came through, right? And there's a big temperature dip, and so it would affect things. So what we could do is increase our accuracy by taking more readings, which is the same thing we said we could do to increase our accuracy when we were finding areas, right? Was to use more intervals, but they're therefore smaller, each of them. So if instead we did every 2 hours or even every hour or even every minute or every second, then we would not be missing as many of these key points and could really average them in and get a true average for the day. So we don't really need a page worth of proof of where this comes from, but remember that the definition of a definite integral involves a limit as n goes to infinity, where that is the number of intervals. And we're used to, when we have an average, we add up how many things we have and divide by how many we have. Well, if I have this interval from a to b, we know there's actually infinitely many numbers between any two numbers, a and b, because we can always go out decimal points. So when we subtract b minus a, we really are seeing how much is there. And so just like we divided by 6 in the example above, or you could think of that as multiplying by 1 over 6, we're going to divide by the length of the interval here. And we get that by subtracting b minus a. So the integral you can think of as adding up. It actually literally is defined with a summation, a capital sigma, because you're adding up heights times width, height times width. And then we're dividing by how many we have, and that's all average value is. So it's the same a to b of f of x dx. The difference is there's a 1 over b minus a. So if you go back to the problem we had finished before, if you were asked about the average daily profit from the get-go, we would need to go, okay, first 10 days, that's 0 to 10. And it's talking about profit. That's going to be from integrating revenue prime minus cost prime. So the setup would be the same, except because it's average daily profit, it's saying, okay, let's say that you sold $100 worth of things in the first 10 days. On average, how much did you sell each day? 100 divided by 10 is 10. But really, maybe what happened was that you only sold $1 on the first day, and then you sold like $20 near the end as business picked up and people got the word out. So on average, in my example, you sold $10 per day, but that doesn't mean that you did it for each of the 10 days. So here this is saying it may not be how much you made every single day, but on average across the days, how much did you make? So we had our previous work and we're going to use it, but I wanted you to have the setup of what this would look like if you were starting it from scratch. The only new thing here is 1 over b minus a, but then the integral is the same as it would have been anyway. So we had already computed that, so we don't need to re-show the work, but then we're going to simply multiply it by the 1/10 or divide it by 10. If it is a 10, then that's nice because that just moves a decimal point. If it's another number, then you would just hop on your calculator and divide. So it says this is the average daily profit, even though it actually varied from day to day. It wasn't that every day, but on average it was. So here's one more where you're given a function and we're asked for average emissions, which is the for this application what it means to find average value. So they told us from 1 to 5, that means we're going to do 1 over the length of the interval, 1 over 5 minus 1, times the integral of 1 to 5 of the given function. The integral is like us adding up things. The fraction in front is like us dividing by how many we have. Then the 1/4 is going to hang out in the front, but we need to do regular antiderivative, right, by adding 1 to the power divided by the new power. We need to plug in the upper limit of integration minus the lower limit of integration, and then eventually we will distribute that forth. Okay? So the very last thing is that we talked about substitution, but at the time we didn't know definite integrals. Most students would get these right. It's just that there's some pretty bad math in the middle. So you might get it right in the end, but you're writing something that's actually a pretty major error in the middle. So we'll have 2 ways you can decide which one you like the best. So when we do substitution, we get things into U's. But what we need to keep in mind is that the limits of integration are in x's, and I can't have a mixture of them being in x's and u's. So we're used to saying, okay, let me choose my u to be the inside function, then its derivative du is what? It's 2x dx. We're used to all that. All we're going to do is also think about the limits of integration when we do those substitutions. If x was 0, and you told me that u is x squared plus 3, that's 0 squared plus 3. So when x is 0, that's the same as u being 3. When x is 1, that's 1 squared plus 3, which is 4. So when we actually make the substitution and switch over to u's, the limits of integration need to be in u's as well. Now the perk of this is that once you do your antiderivative and you usually would then switch it back to x's. But remember, you already put in the time to switch these to be used, the limits of integration. So you don't need to switch back to x's because you have the equivalent version here in u's, and then you've converted everything to u's. So once you do the antiderivative, you're going to plug in the upper limit of integration minus the lower limit of integration to get your answer. I recommend that way. There's really no reason not to do it. You're already switching over to use, so we just need to switch everything over to use. But if you want to avoid that, the other option is to first just think of the indefinite integral first, because the first step of this definite integral was to do the antiderivative anyway. So if we think of the indefinite integral first and we do any substitution that we need to do, then we can put it back into x's, and what we've done is we did the indefinite integral and there was a plus c there, but we know when we do a definite integral, everything but the plus c is going to be our first step anyway. So now you can go, you're already back in x's, it's okay to have 0 to 1 because your variable is x, not some u that has gotten changed up above. And so then you're ready to plug in your upper limit of integration and your lower limit of integration and subtract. So the idea here is to kind of avoid the issue, do it as an indefinite, remembering that the first step of the definite will be that answer anyway, and then actually evaluate it with the 1 and the 0. Or in the other way, you just, while you're in the practice of solving for u's, then make sure that you rewrite the limits of integration as u's as well. Alright, so that is it for that second to last section in class, and we covered the rest of it with average value, and then what does it look like to do a substitution problem when you have a definite integral now that we know about both. I hope you found it helpful.